So hello everybody, we are dealing with problem number 1.180 and this is the series where we are dealing with variable mass system and the motion of rocket. So I hope you have watched problem number 1.178. If you haven't, then kindly give it a view. Otherwise you will not be able to understand the concept which we are using in this problem, because we start this problem with the working formula ma equals f minus mu u, where m is the mass of the rocket, a is instantaneous acceleration of the rocket, f is the external force, mu u is the thrust force, where mu is the rate of ejection of mass and u is the relative speed with which the gases are ejected from the rocket. Now the problem is stating, find the law according to which the mass of the rocket varies with time. When the rocket moves with a constant acceleration a, the external forces are absent, the gas escapes with a constant velocity u relative to the rocket, and its mass at the initial movement equals m naught. So as we approach this problem, the problem is stated that the external forces are absent. So we can say that f is equal to 0. So since f is equal to 0, and acceleration is mentioned as constant, acceleration is mentioned over here as constant, and at t equals 0, m equals m naught, and we are asked to determine the law according to which the mass of the rocket varies. That is, we need to evaluate what is the mass at a time t. So at a time t, if the mass is suppose mt, so we are asked in this problem to determine this mt. This is missing in the problem. So if we start this problem, then we can say that ma is equal to f being 0 minus mu u, and therefore we can write that acceleration a is equal to thrust force divided by mass, that is u minus dm by dt divided by m. So we have an equation like this, and hence we can say that if we arrange the terms, acceleration being constant, then we can say that dm by m is equal to minus a by u dt, and if we integrate both sides, then we can use the simple expression that at t equals 0, mass is m naught, and at a certain time t, mass is equal to mt, and hence if we write it in logarithmic form, ln mt by m naught is equal to minus a by u into t, and hence we can write this expression as mt equals m naught e to the power minus at by u. That is, we can say that if the rocket is moving with a constant acceleration, then the mass is exponentially decaying with time. The mass of the rocket is exponentially decaying with time, and we have obtained this expression mt equals m naught e to the power minus at by u. This is the final solution of the problem number 1.180.